Hello everyone, we are back for another video this week. It's gonna be more of a tutorial about TCP dump, and we're gonna be sniffing packets, and hopefully we're gonna be catching some passwords in plain text. This video is gonna be like for all levels. Everyone can benefit. If you want to do a refresh about TCP dump or Wireshark, this is actually a very good place. We're gonna discuss a bit of networking concepts so you guys can understand what you are reading from TCP dump. It's to be a actually good professional, you have to kind of have a bit of a background in networking and understand basically what the tool is capturing. So let's not talk a lot about it and let's actually start. So first I wanted to show you basically the basic help menu from TCP dump, and you can see here basically that TCP dump has many flags, and you can see basically what each flag means. And basically some of them, for example, -C is important because you can basically specify for TCP dump how many packets to capture before it stops. You can tell it to read from a PCAP file, you can tell it to write to a PCAP file. There are other options that we're gonna probably discuss throughout the video, so stay tuned. So let's not take a lot of time and let's actually start, like actually sniffing and actually see data being captured. So before we start, I want to also mention that for you to be able to sniff packets, you have to understand the concept of network card interface. A network card interface is basically the physical hardware that you have that basically send and receive data from the internet or to the router or other machines. Basically, it's like the sender and receiver of packets. Now, you have to understand that you might have more than one on your machine. And to figure out what do you have on this machine, you have to use a certain command. In this case, on our Ubuntu, we're gonna use the ifconfig command to see what we have. And as you can see here, we have two. We have ENS33 and we have LO. So the LO represent here the local host itself. You can know that by checking the IP address, which is 127.0.0.1, which is basically an IP address that's reserved for localhost. And basically any traffic that is forwarded to that specific local host basically is gonna be done on this interface. However, all other traffic, for example, I want to access google.com, I want to access any website on the internet, basically all the traffic was going to be routed through the ENS33. And to actually prove that, we're going to first start with, for example, we're going to do a simple TCP dump. And just for you to know, if you want to capture packets, you have to be root on your device. In this case, I already am root. If you don't know how to become root on Ubuntu, basically it is sudo su dash. So you do that, you put your password and you become root. So basically we're gonna run the TCP dump. I'm gonna specify the LO interface, which is basically my local host, and I'm gonna press enter. Right now it's waiting for anything to hit my local host for it to be captured. To do so, we're gonna trigger that manually. We're gonna try to ping our local host and see what we get. Okay, and here we have actually multiple attempts that happen from our command. As you can see, guys, we sent 4 packets. On this side, we have 1, 2, 3, 4, around 8, I guess. Yes, so we have 8. And as you can see, let me make it a bit bigger. So as you can see here, basically, we have first a NIC request. So if you guys are not familiar with the ICMP protocol from ping, basically, whenever you send a request, if the device exists and there is an ICMP allowed, then it's gonna send us a reply. And since we sent 4 packets, our local host replied with 4 replies. So we sent 4 requests, we got 4 reply. And you can see basically the timestamps, what the layer 3 protocol used. You can see source host, destination host. And in this case, it's localhost because we are pinging the local host. and you can see the protocol that was used in this case, layer 4. I will not say layer 4 in this case, it's more of layer 3, but ICMP protocol was being used since we did ping. And you have basically what method was used. It was echo request. You have the ID, sequence, and length of the packet. So let's stop the TCP dump, and we stop it by Control C. Then let's clear, and let's minimize the window. So in this case, now we understand basically the basic functionality. You have to specify the interface, and you have to basically send packets or have something that's actually working on your device. So I'm gonna do the same thing. However, I'm gonna basically add another option, which is gonna be -n, which basically means do not resolve host names, and basically show me the data raw if you want. And we're gonna use this time ENF33, and this time we're gonna ping google.com, and we're gonna do it one time. We're gonna only send one ping. So let's do it. And oh, wait, sorry, I did not run the command, so let's do it again. And let's stop the capture. So let's make it big again, and let's see what happened. So basically, those are all ARP requests, and actually not all of them. Some of them are actually related to Google itself. So let's actually look at what happened. So when we first sent ping google.com, computers don't understand hostname. They need IPs. So the first thing that my machine did is actually to go and, as a DNS, what the address of google.com. We have A and quadruple A's. So what the difference between the two? 1A, if you see here, we have our host machine, which is, this is my local IP. And it's basically sending to the DNS server on that IP, right? And then we get the same reply from this port, from port 53, which is port of DNS, back to our host from the same source port. So now we got the IP of 142.50.69.142, which is basically the IPv4 of google.com. And then we also received the IPv6 of google.com from the same DNS server, and it's this. Now, what happened after the DNS resolved the domain? What happened is, in here, we actually send the ICMP request. And as you can see here, the ICMP echo request was sent to the same address that was given by the DNS server. You can see it here. And then you can see from the same IP, we received an echo reply, which basically acknowledged that the google.com server is actually online. And this is how basically we can capture. It depends. What are you trying to capture? And you can basically filter down on the data that you want, but that's probably a more advanced video that we can probably cover in the future. So in this case, I want to move forward by showcasing that capturing passwords is not as easy as you can think. It is definitely feasible depending on what kind of traffic is happening in your environment. If most of the network protocol that you are seeing are not encrypted, then the possibility of you capturing raw passwords and confidential information is high. However, with time, this has been, like seeing unencrypted traffic has been on decline because of now everyone is pushing to use TLS to protect data, to protect privacy for everyone. So what I did for me to showcase that it's actually possible to capture password, I have actually initialized a HTTP service on my localhost. Okay, so I'm gonna go to the web browser, and as you can see here, I already have a login page. and we're gonna use it basically to test the TCP dump, right? And let me clear here a bit to make it more clear. Same here. So so first, let's start by creating our TCP dump. Since my web server is on the localhost, basically what we want to do is to first specify the interface, correct? So since it's a localhost, so we're gonna put the LO, which basically the interface of my localhost, and I'm gonna add something in here that is gonna be first, do not resolve, just like we did before, and we're gonna add port 80. Why am I adding port 80? I'm adding port 80 because the web service on my machine is running on that port. And instead of getting all the garbage, I just want to be focused for any communication that's happening toward port 80 or being received from port 80. So we're gonna click now on to run. You know what, before that, we're gonna add one more option, which is gonna be -3. And the idea is to capture basically the first 3 packets. Why am I doing so? It's because I want to show you a network fundamental concept of the 3-way handshake. So we're gonna refresh this page and hopefully I'm gonna have some data. And here we go, we actually do. So as you can see, this we have the timestamp, then we have which protocol, and then you have basically the source. This is the source IP, this is source port, destination IP, and then destination port, which is port 80 that we specified in the command. Then you see flags S. What does that mean? Basically, it means this request is a SYN. This is a TCP connection with a SYN flag enabled. And then you can see the sequence number and all the other options. So that basically means my local hosts send a SYN to my local web server. Afterwards, we can see that my web server that exists on port 80 on my local host send back a SYN-ACK, right? And as you can see here, the acknowledge is actually the sequence number +1, which is basically, if you check the RFC of TCP, it makes sense. Afterwards, my client on the local host send back to the web server ACK. So we have SYN, SYN-ACK, and ACK. And this is how basically in this case, my web browser establish a 3-way handshake with my web server on the local host. And basically every time you access a website, this is what's actually happening in the beginning. We are establishing the TCP 3-way handshake before any other communication is taking place. So now let's do clear and let's try to run the same command again. However, let's remove this time the count. And now let's add another option, which is gonna be -x, which basically gonna show the packet with basically ASCII and hexadecimal. So let's run, okay. And this time, what we're gonna do is we're gonna send actual data. So we're gonna refresh and we're gonna send an actual username and password, admin, and we're gonna actually send password 123, and then we're gonna press login now, and we have login successful. So let's go back here and see what actually happened. So first, you have to understand that we have sent multiple data, and you can see basically here all the communication that happened. So you can see it all in hexa. So you have the SYN, you have the SYN-ACK, you have the ACK, and then now we have the push ACK, which basically my web browser is sending data. And the first thing that it did is it did get. Get is an HTTP method to basically get the web page, and it did get the web page. Basically here it did get /. If you look at the browser, so first if we remove the login.php and we go back, it's basically the login page. So first, my web browser took the login page in here. You can see the user agent, it's Mozilla. You can see that it's an Ubuntu Linux. This first Mozilla is actually like that most probably exists for all user agent, but how do you actually know it's Firefox is by the second. After the Ubuntu, you see Firefox here, we know it's a Firefox. Now let's go down a bit to see what happened. Here we get an ACK from the server. Basically, it received our request and it gave us a page. Okay. Afterward, after I put like my username and password, probably what happened in here is we send the data. Now let's try to check the data within here. So here, as you can see, we have a push ACK. And it means this we send another data now because we have this IP and we're sending to the web server. Like you can see, destination port is 80. You have a post. We are posting toward this page of the HTTP server. And you can also see basically that the user agent, what application we use, and you can see basically that we have used the Firefox on an Ubuntu system. Now let's try to see if we can find the username and password. If you did not see it yet, it's in here. You can see that we have username equal admin, and then we have password equal password123. And you can basically see that the password, the credential in plain text. And then after we put the credentials, you can see basically the web server replying to us with a login successful. And even you can see basically the server version. And I actually do have an Apache 2 web server enabled. And this is basically what we see here. So as you can see, this is kind of easy to be able to sniff username and password if you have the right place on the network. Now, if you are an actual attacker, you can basically abuse this. Let's say you are working in an environment where basically your web server are not secure with TLS, and somehow you get a foothold into this company. You can run Wireshark or TCPDump to capture all traffic to that service and start collecting credentials. And even maybe, even though there could be a TLS encryption, if you are lucky enough and you are on that server and you happen to maybe like the administrator of that server is, like made a mistake or forgot or he did a misconfiguration, maybe you will actually find the private key of the encryption, and then basically you can decrypt all the data. And this is actually very powerful. If you are an attacker, you can use TCPDump in ways that is actually scary, I would say, because you are capturing everything. And if you want me to do another video regarding like capturing packets from a wireless network and see basically what everyone else on my network is doing by being man in the middle, I would definitely would love you guys to actually send in the comment this request. So for sure, like that could be a topic for another video. I wanted to showcase one more thing. I wanted to showcase that you can actually also store packets into a PCAP file. To do so, you have to first specify the interface that you want to use and where you want to write the PCAP file. To do so, what you have to add is you have to add the -w, and you can specify basically what the name of the PCAP is going to be. So since we are using HTTP, we're going to call it http.pcap. Okay, and we're going to be on port 80. So let's run this. And this time, let's try to use curl to send the username and password to the web server and try to catch that. So to actually do this, I'm gonna get the command real quick. Don't have it memorized, but basically it's gonna be something like curl. Oh wait, sorry. Gonna be curl-x post, and then 1 second. Okay, it's gonna be dash post http localhost. Since we are sending the credential to the login.php page, we're gonna basically be sending in the body username equal admin and password equal password 123. And as you can see, we have received from the web server again login successful. Now let's stop and let's check if we have actually a PCAP file, and we do. We have the HTTP PCAP. Forget about the password.pcap, it's actually like a totally different PCAP, but this is basically what we have collected. One way to check the PCAP file, we can use Wireshark, or we can even use TCPDump. If you want to actually see it, you can do it but with using TCP-R basically, and you can specify the PCAP file, and then you can basically see what's inside. But I also wanted guys to show you a bit of Wireshark, so we're gonna do that. And wait, let me see why it's not working. Huh. It was working just before. Check. Okay. Okay, for some reason the Wireshark is not working, so we're gonna have to stick with TCPDump. In this case, TCPDump-R to read the file. Okay, so the file is http.pcap, and then we're gonna do -A to see basically the ASCII, and we're gonna hit enter. So here we see all the data. We see everything. We see all the PCAP that we have captured. So it starts from here. So as you can see, basically you can see the username and password that was sent. You can even see what user agent. In this case, since we used curl, the user agent was curl. So it's very important to understand that you can kind of fingerprint the attacker or at least the user by their user agent, even though it can be, you know, like spoofed, but most of the time people don't go through the hassle of it. You can also tell here that the server is Apache 2.4.58 and basically that the login was successful. Anyway, that's all for the video. I thank you guys for watching. Drop down in the comment section if you want me to do a Wireshark video or to explain any more networking concepts with proof. It was nice doing this video, guys, for you. Please follow and subscribe to my channel, and hopefully I get a like on this video. Thank you, guys. Bye bye.